Here we go, lesson 2.8, two variable inequalities. Now remember, an inequality is an equation with a less than, greater than, less than or equal to, or greater than or equal to symbol instead of an equal sign. So an inequality with two variables has infinitely many solutions bounded by the graph given. Excuse me. So if we had an equation of the line, like y equals mx plus b, we would graph that line. This is just some random line. It says less than, so that means that all of our possible solutions are going to be underneath that line. And so we would shade beneath that line. If we had an absolute value graph, and it says y is greater than or equal to that, we would, this is a bad line, we would graph that absolute value function, and then greater than, we would shade above it. And again, what the shading means is that every single thing in the shaded region solves that inequality and makes it true. When you're graphing your lines, you need to use either a solid line or a dashed line. If it's less than or greater than, you'll use a dashed line. If it's less than or equal to or greater than or equal to, you will use a solid line when drawing your graph. So again, shading, if it's shaded, it's a solution. If it's not shaded, it's not a solution. So let's look at the point 0, 0. Is it a solution for each one of these graphs? In the first one, 0, 0 is not included in the shaded region, so 0, 0 is not a solution. Over here on the right, 0, 0 is included, so 0, 0 is part of that solution. Graph the inequality here, looking at y is less than or equal to negative 2x plus 5. This sure looks a lot like y equals mx plus b. So we'll graph it just like y equals mx plus b. Our slope is negative 2 over 1. Our y-intercept is 5. We are going to have a solid line when we graph it. And we are going to shade less than. So we'll start with B, which is our y-intercept at 5, 1, 2, 3, 4, 5. Then we'll use our slope, down 2, right 1, down 2, right 1, down 2, right 1. You could have also gone up 2 and left 1. It's less than or equal to, so that means that we will have a solid line going through these points. And then it is less than, so we're going to want to shade below it. Now, sometimes it's a little confusing figuring out where we need to shade. So what I like to do is I pick a point. Usually I try to pick 0, 0, because that's just an easy point to work with. What you do from there is you plug it into the original equation and see if it makes a true statement. Is 0 less than or equal to negative 2 times 0 plus 5? Is 0 less than or equal to 0 plus 5? Is 0 less than or equal to 5? Yes. So that means that 0, 0 is part of our solution set. So when we go to shade, we want to make sure that we shade on the side that includes 0, 0. And we are done. Graph the inequality y is greater than negative absolute value of x minus 2 plus 1, and this sure looks a lot like y equals a times absolute value of x minus h plus k, where h and k are our shifts and a is our slope. So if I look at this graph, it's telling me to go to the right 2, it's telling me to go up 1, and my slope of my absolute value graph is going to be negative 1 over 1. I'm going to use a dashed line because it's just greater than, and I want to shade in the greater section. So if we start at our vertex, it tells us to go right 2 and up 1, and so that is where we'll make our first point for our vertex. Our slope then tells us to go down 1 and right 1. And then we need to mirror that the other direction, down 1 and left 1. We're going to use a dashed line to connect our points because it's simply less than, greater than. There's no or equal to on that. And then it says, again, to shade greater. I'm going to pick a test point. I always like using 0, 0, and I'm going to see if it makes a true statement. Is 0 greater than the absolute value of 0 minus 2 plus 1? Is 0 greater than the negative absolute value of negative 2 plus 1? Is 0 greater than negative 2 plus 1? Is 0 greater than negative 1? Yes, so again, that means that 0 is part of the solution set, so we will shade on the side that includes 0, 0. Now, if we had worked this out and it had given us a false statement, like 0 is less than negative 1, then we would have shaded on the opposite side, the side that does not include 0, 0. But here, because it created a true statement, it means it is part of the solution, so we shade that side. Now here we're going to work backwards, write an inequality for the graph below. First of all, I see it's a solid line. Oops, let's get a thinner pencil. I see that it's a solid line, so that means that I will be using an or equal to. I see it's shaded below, so that means I'm going to use less than. Then I see it's an absolute value equation, so I need to write one like that. So y is less than or equal to the absolute value. Let's see how it shifted. I know that when I have my x, I'm going to move to the right 1, 2, 3. So that means I'll have x minus 3. Then I see that my graph went down 1, 2, 3, 4, 5. So minus 5. Again, our shift was to the right 3 from the vertex 1, 2, 3, and down 1, 2, 3, 4, 5. That's where my new vertex is. Now I need to count my slope. It looks like I go up 1 and right 2, up 1, right 2. So that means my slope is 1/2. Let's check to make sure that we plugged it in correctly. I'm going to pick the point 0, 0. If it is part of the solution, then I wrote my equation wrong. If it is not part of the solution, since it's not highlighted, then I wrote my equation correctly. Is 0 less than or equal to 1/2? 0 minus 3 minus 5. Is 0 less than or equal to 1/2 the absolute value of negative 3 minus 5? I don't know why I wrote 3 minus 5. Is 0 less than or equal to 3/2 minus 5? We need to give them common denominators. And when we do that, we'll multiply by 2 over 2 and get 10 over 2. And so is 0 less than or equal to negative 7 over 2? 0 is never less than a negative, so that should not be part of the solution. Again, 0, 0 here is not in the shaded region, so that means that we wrote our equation correctly. And this is our answer. So our joke of the day, what do you call a cow with no legs? Anyone? Ground beef.